Over to you, Dr. Mukhopadhyay.
Very good morning to all of you. It is a great pleasure and privilege for me to give a presentation on sustainable mobility and circular economy, challenges and opportunity for tire and rubber industry. I am very much thankful to the RMIT University Management, especially the Professor Namita Roy Chaudhary and Mr. Philip, to give us an opportunity to present these topics. Now, this presentation has got the two parts. What I will do initially, 2 or 3 slides I'll show from the organization which it belongs to, especially JKTR and our institutes. And then subsequently, I will follow the lectures presentation. Let me see this, our JKTR at a glance. Okay, sorry. Yeah. JKTR, the vision, actually JKTR is one of the, if you looked into this about the hundreds of about tire companies, JKTR position globally is the 19th rank, the top tire companies in the world. And our vision be a green and trusted mobility, the first one. And the mission last one, you can see that reduce carbon emission intensity 50% by 2030 and carbon neutrality by 2050. So this is the work because as a common man, they know the tire industry is a polluted industry, and our most of the research based on the how we can convert it to the public mindset to the it is a green industry. And we are the pioneer in the radial technology in India, 1970s, and we are the #1 positions in India in the truck was radial manufacturers. We have the start of the art of R&D Center, which is name of the chairman Raghupati Singhania Center of Excellence. And it is the first company in India with the original equipment manufacture of the tubeless tire, the pneumatic tire, which was developed in 1886. And really, it was tube type, and it is the whole world is moving the tubeless. So we are the first in India. And we are the first in India to launch the tire pressure monitoring system. As the world is moving from digitization to the sensor, we apply the sensor technology in the tire to measure the temperature, pressure, inflation pressure, and so on. And we are the globally among the top 3 lowest energy consumption in the world. And the water consumptions, we are the first in the world. And we are the first tire company in India to receive the International Sustainability and Carbon Certification, which is called ISCC. These are if you looked into that, we have a 12 manufacturing plant around the world, 9 in India and 3 in Mexico. And this we are manufacturing from the 2-wheelers, 3-wheelers to the, which is weight about 1.5 to 2 kilo, to the OTR tire, which is weight about 3 tons. And the height is around, let us close to about 15 feet. And the cost is abnormally high. And we have a total capacity about 34 million tires, which are expanding to 40 million tires. And as I rightly considering, we are exporting more than 100 countries. Regarding our research institute, this is the building oval shape. This is research building. You see that this is oval shape. Completely, it is a green building. We are using completely the light, natural light we are using. We are using rain harvesting water, about 30% of water from the rain. And also we have a greenery around this. And we have about 235 scientists are working in the research about the 100 and plus, and the development section is around the 135. And our institute is recognized as a scientific and industrial research organization by the Department of Science and Industrial Research under the Ministry of Science and Technology, Government of India. Our institute is affiliated for PhD program from the different universities in India. And it is accredited by as you know, that each laboratory has to be accredited by the National Accreditation Board of Laboratory, which has an agreement of the Asia Pacific Laboratory Accreditation and International Laboratory Accreditation. So any test result we provide is accepted globally. And we are the proficiency testing power because our laboratory being used by the other tire industry as a proficiency testing. And we are the first in the world and only laboratory for the tire rolling resistance measurement by NABL. So anybody want to get accreditation, they have to send the tire, whether it is a Michelin or the Bristones, to our laboratory. Uh, our vision is that to become a primary industrial research institute global report in the field of elastomer and tire technology. And our mission is technology self-reliance through innovative approach, collaborative and sponsored research through industry academic interaction, and leadership role in the developing skilled manpower. As you know today, skilled manpower, India is going for manufacturing, China plus India policy will require a skill. So we are creating the center of excellence for polymer science and rubber technology, and we are providing weekly course in line and also the practical courses, and to be world-class testing laboratory. So we are doing manpower development as well as the research, industrial research, and also academic research. See, before going to the my topics, what I would like to say a few words. This today the economics today have a today our economy is the fruit based, and this economy is developed when the earth housed with 1 billion people. But today we have more than 8.2 billion people. The crude-based economy has got a certain problem. So that's the reason's problem is a lot of greenhouse gas emissions. And you're surprised to know these 8.2 billion people, they consume about 1.6 times what the natures can produce. So out of which, and if you look today, which industry is mostly polluted, and there are the three. One is the energy sectors, and second is the agriculture, third is the automobile sector. Automobile sector produces 23% of the greenhouse gas emission globally. Today we have 1.2 billion vehicles for the 8.2 million people, and by 2050 the population will be close to 10 billion, and the vehicle population increased to 2.4 billion. If you let show, and if you continue the technology what you're doing today, imagine what should be the how we can save our mother plant. Now, this is one of the major chiefs. If you look, the other challenges is the environmental challenges. What is environmental challenges? That is one thing is the climate change. You see in the worldwide, if you see that there is a flood, there is a tsunami, there is an earthquake, but who is responsible for that? This as per the recently the COP meeting on 27 and 28. First thing started in Paris Protocol, the Kyoto Protocol in 1995, and subsequently the Paris Protocol. Last is the Glasgow. What are the things world leaders they have come to point? We should not allow the temperatures of the earth to go more than 1.5 degrees centigrade. If we allow this thing, this temperature, if it's for, the every degree centigrade increase, if the temperature goes to 2.5, automatically survival of the mother planet is a question mark. So whole industries are working together, including the government, how to keep the temperature is 1.5 degree and below. But the last 2023, the temperatures which goes in September, October globally, it has gone to the close to 2 degrees centigrade. So that's the reason today everybody is trying to see that how the industry, academics, and also the government together, how to keep the carbon work towards the carbon neutrality. Now, second point is the urbanization, the demographic shift. Today, if you looked into that, the most of the people they are sitting in the urbanizations, and that gives a problem. And by 2050, two-thirds of the population globally will live into the urban city. So and second point is a demographic shift. So third is the growing and aging population and growing mobility. As you know today, the 65 plus population, if it is 65 plus population, we have a 1 billion plus, and by 2050, it will be the 2 billion. You see that the mortality rate has improved, so that is another problem. Second is the new field, the energy demand. Today, globally, about energy percentage per annum increasing about 1.5 to 2, whereas India and China, the energy consumption is, since it is developing, so they are energy consumption 10 to 11%. Now, by 2030, India and China consume 50% of the global energy. And energy source is the basically today the coal and subsequently to the crude. And in India presently, what I consider about 70% of the greenhouse gas is coming from the thermal plant. That's the reason our Honorable Prime Minister mentioned whole world leaders said by 2050 they will be carbon neutral. India took a challenge about 2070. Since we have to grow, that's the reasons we are gradually converting to the thermal, to the solar and the wind, subsequently the nuclear and hydrogen based. Next point is the new field IT, bio and nano and cogno. As you know, every 20 years the technology changes. 2000, 1980 to 2000 information technology, 2000 to 2020 the biotechnology, 2020 to 2040 it is the nano, and 2040 and 2060 it will be the cogno. Cogno is human brain to brain interaction. Next is the emerging technology, the IoT, AI, robotics, sensor, machine learning, 3D printing, and last but not least is called the new mobility. New mobility is the case. Case means connected, autonomous, connected, autonomous, autonomous, and the share and the electrical vehicles. Ultimately, you know that shared is the Ola and Uber. There's the same asset being used by the different people. And the electrical vehicles, I will try to explain subsequently. And the autonomous is the driverless car. And the connected means is not necessarily one driver followed by the commercial vehicle 30 trucks. You don't require so many drivers. So the sensor will take that one driver in the front will be sufficient enough. Next comes is the finite resource and infinite demand. Today, our major source is the sorry, the non-renewable to renewable. How we can go? That means today most of the crude-based economy we have the crude refinery. How we can convert to the biorefinery? As all of you know, the energy source is the two things. One is the animal origin. Second is the plant origin. Today the animal origin is the crude we are using. Tomorrow the plant. Everything has to be comes from the plant. Even today in the rubber industry, we are using the polymers coming from the crude refinery, but already, as you know, the sugar cane to the molasses to the alcohol to the styrene or butadiene. That means you can do the styrene, butadiene rubber, polystyrene from the plant origins. Sorry. Second is the legislation and regulation. So each country, there is a stringent legislation and regulations are coming to save our mother plants, that how to reduce the greenhouse gas emissions in automobile industry, what is happening will change. Second is the changing the consumer demand. What the young population want. They want sustainable lifestyle. Sustainable lifestyle means they require the fresh oxygen or the fresh air and the fresh water. This is the lifestyle and they don't want to make the earth polluted. I hope with this background, I would like to show them what is the alternative. Now, what if they think over it? What if there is another model that can give the humanity a hope? Let us look at the nature. For the millions of cycle, uh, if you see the millions of years, it is worked and survived without generating waste. One element, waste, is another one resource, and the growth in nature is always balanced by the multifaceted. While certain ecosystem grow, other decline. While there is components are recycled, this interplay of the growth and decay allows the organism, the system, to reach their potential and create a balance. This is precisely the ambition of the circular economy, an approach already been used to build the sustainable and impactful business. with growing scarcity of material resources and the exponential accumulation of the waste, our linear economy model is panting that the circular economy offers a sustainable alternative that value in the long term for the business, the people, and the planet. So one of the today's challenge is to scale up this circular innovation growing worldwide and to do so quickly. So the solution is the sustainable growth in a way to grow that it creates the both economic and the societal values, which is called ESG, environmental, society, and the governance at the same time. And really, this is really what is the overall environmental impact to be reduced in a factor of 10. This will be this require unprecedented innovation and the technology, and only the lasting and sustainable way to survive our mother plant. Now, this is the background of my lectures. I hope you realize what is the importance of the keeping our mother plant green. Now, this is this type of directly here showing this the four types of the economy. First is the linear economy. What is the following: take, make, use, and throw. That means we extract the material from the earth, then we manufacture it, then we use it and then throw it. Now, you're surprised to know the 50 million tons of the waste material is available for recycling. But what is the circular economy? You see, the circular economy, after you can procure the extraction and you manufactures, then you transport, distribute, and then use it. After use it, what you can do it, that is very clear: repair and reuse, first things, and repair and reuse. Second, the end of the life, instead of disposals, the reuse, then remanufacturing on parts. You might have known the second-hand car, the reharvestings and others. Similarly, recycle of the materials and recovery and resource extraction. That means reduce, reuse, recycle, regenerate, refurbish, and sometimes is refuse. So these are the certain methodologies you have to follow. But tomorrow, the employment generation will be only from this industry, recycling industry. Now, third is the shared economy. Shared economy, already I have explained to you, the sharing the asset by the different people, sharing the platform by the different students. Then what is the green economy? Green economy means first you have to be the low carbon growth. Then we have to go for a resource efficiency, that is produce more with the less material. Continuous weight reduction. That means if you have to do continuous weight reduction, what you have to do? You have to use the stronger and lighter material. Both they reduce the weight and stronger. There's a material innovations is required. Third is the social inclusive. That is produced a product or manufactured a product which is acceptable. Today, as you surprised to know, out of 8.2 billion people, about more than, it is very clear what is the world data is more than about 5 billion people, they are under the poverty line all over the world. So we have to technology innovation to be developed for those guys. This is called the social aspect, the social inclusivity. That's called the green economy. That means ultimately it is called sustainable development. Next comes about what is the yeah. Now this definition I don't want to go too far. All of you are aware of it. What is sustainability? That means the ability to maintain or support a process continuously over a time. What you develop, is it sustainable? Number one. Second is circularity, already told, step towards sustainability practice, which focus reducing waste as much as possible, converting waste to the well. Converting waste to the well. Sustainable development, this event definition, is a development that meets the needs of the present without compromising the ability of future generation to meet their own needs. That means we have to keep something for our future generation. Next is what is sustainable mobility. This is the United Nations definition. The provision of service and infrastructure for the mobility of the people and the goods advancing economy, social development, benefit today's and future generation in a manner that is safe, affordable, accessible, efficient, and resilient, while minimizing the carbon, other emission, and environmental impact. Because today, actually, mobility of the society depends on the transport. So we cannot move, we cannot say that we don't require the automobile. We do not require a commercial vehicle. We do not require a plane. So this is so how we can make it more greener. That is a challenge. Now, this is actually, if you looked into this slides very nicely, that means these are the three corners of the triangle. One is the environmental you have to protect. Second is the economic. Third is the social. When you say that the environment, that means the way you are manufacturing, the way the product performing. Suppose you make a product, the build to last. Suppose today a product is giving, in case of tire, there is initial mileage is giving 150 to 200,000 kilometers. So after retrading, it can give a 600,000 kilometers. Now we have a challenge, can you make to the 1 lakh kilometers? That means you require less materials, you require a energy saving, you require a land saving and so on. So that means build to last. Similarly, the economics point of view, risk management, your all stakeholder you have to look, and companies means employee, stakeholder, and suppliers. So this I will explain gradually as we go. And this is called what is the sustainability criteria? This is a very important part. First is environment. I don't want to explain further. Second is the labor human rights. That means forget the use of child laborers and others. And you have to give a social equality. Third is the ethics. There is the corruption, anti-competitive practices, responsible information and management. Last is the sustainable procurement. In rubber industry, let's consider about 65 to 70% cost is the material. And out of which 80% materials are petro-based. So that means, suppose it is very clear, we are using a carbon black. And this carbon black being manufactured from the crude and very high temperature, 2200 degrees centigrade and quenching to 900 degrees centigrade, you get a, when a hydrocarbon is split it, and then you quench it, you get a carbon black. So the amount of carbon dioxide generations is about 90% of the tire industry responsible for the carbon black manufacturers. Next comes the steel tire cord. Now, steel tire cord, as you know, it is coming from the blast furnaces. So a lot of energy is going. So how can this steel can be, instead of blast furnace, can you do the arc furnace? So energy, it is about 80%. Third is comes of the organic tire cord, polyesters, nylon, and etc. Fourth is coming for synthetic rubber. So these are the four major raw materials, and they are the highest amount of the greenhouse gas emissions. So what is considered supplier environmental practice, number one, supplier social practice, with their suppliers, they are getting from refineries and others. Next is the supplier enforcement practices with their suppliers. That means polymer industry, tire industry, they have to say how the suppliers are taking. Otherwise, whole supply chain, we can do a good job. But if the suppliers is also highly energy intensive, automatically the total carbon neutrality work will not in the right directions. Now let us be clear. This is a very interesting slide. What is the international regulation? Especially what is net zero? How to get the net zero? Now, net zero is the target, negating the amount of the greenhouse gas produced by human activity and reducing emission, implementing method, absorbing. That means we require a product, we have to manufacture, there will be greenhouse gas emissions. How these greenhouse gas emission can be nullified. The amount of greenhouse gas you produced, amount you absorb. If you are a carbon positive, then you are working towards carbon neutrality. How you can do it? There is a four ways of doing. Number one is the material transition. You might have seen here, the material transition means petro-based to non-petro-based. Number one. That means material chemistry has to look how we can reduce petro to non-petro-based. Second, energy transition from non-renewable to renewable. That means you have to forget about the coal or any thermal or the crude. You may have to go a step with CNG, or then you go for let us very clear, wind, or we can go for what is called here considering the wind energy is there, this picture, wind energy is there, then solar power, then you go to, what is called LED or CFD, but this is not sufficient enough. What you are considering, you have to completely convert to non-renewable to renewable. Then third is the waste transition. That means waste reduction every stage. So you immediately waste to be utilized. Wasted, not only the waste reduction during manufacturing, wasted resources, wasted capital. When you say the resources means, any manufacturing require water, steam, air, power, all these things has to be reduced. Wasted capacity, wasted lifestyle, wasted embedded values. That means all types of waste generating during manufacturing has to be reduced. Now, if you looked into if you do only solar power, the business as usual, how to reduce carbon removal technology? These are the waste. Second is the afforestation. Instead of deforestation, you have to do the afforestation. Second is the carbon capturing technology. There will be a carbon greenhouse gas emission. The Exxon, especially if you looked into that, they are doing excellent job. They know that this is the business near futures. Whatever the greenhouse gas we are doing, that has to be captured. And there, I will explain that one. See the left-hand side, my picture. What is our commitment from India? COP20. Every country has committed. This is when there is a. This is the Paris Protocol, and after the Glasgow, it is ratified by the Indian Parliament that non-fossil energy capacity to 500 gigawatt by 2030, 50% energy requirement via renewable energy, and reduce 1 billion carbon emission by 2030, reduce carbon intensity greater than 45%, and achieve target of net zero by 2070. So every country has given this target. Most of the developed countries, they are giving by 2050 of the carbon neutrality. Now let's consider why you go for carbon neutrality. This is the one survey done in UK. If you see the different types of the transport, the carbon dioxide equivalent emission per passenger kilometers. If you use the cruise ship of 250 grams, domestic flight 246 grams. If you down to the earth, what is considering, if you looked at the electrical vehicle, 47 grams. Where is the railways or the tram or buses? So let me consider the mass mobility. Instead of individual mobility, if you go for a mass mobility, automatically per capita, the reduction will be sufficient enough. But electrical vehicle, one is thing, they can make the city clean. But ultimately, the charge has to be done by our normal source of energy, by thermal and other. If you looked into the electrical at the sense, until unless these electrical charges can be done by the solar or any other alternative, the renewable energy source, then you can see electrical vehicle is really eco-friendly. But yes, for city cleanness and other things, they don't produce the greenhouse gas emission. City will be much cleaner. That's the reason people are going. How the automobile industry is going? Initially, it was IC engine, then comes the hybrid, then comes the EV. Subsequently, what will come in emission reduction? Ultimately, this will come fuel cell or ultimately hydrogens. That means we have to work on towards the hydrogen economy. Now, if we looked into this, this is very interesting that greenhouse gas emission country-wise. See what is the cost of the greenhouse gas emission? As you know that today, every country, the European country already this got carbon tax. That means if we have to India, still we are manufacturing, you have to export to the India. If we do not have a green technology, that will be charged. India and China, whoever is doing. That means what the developed country is doing, that means since the greenhouse gas emission is going up rapidly, the country wise, that means those who are exporters, they have to develop their product with this green technology. That's the reasons the sustainable mobility is very important. Now, if we looked into that, what is the 5 business model? How to go for sustainability and circularity? One is but before that, I want to say the another terminal is called decoupling technology. Decoupling technology is that means the growth of the country will go, economic growth and as well as human well-being. But how we decouple the growth with the resource consumption? What is our capacity? Let us very clear. Today, we know that we have to produce more material. That means how can decouple with the less material, same performance. That's called decoupling. Second is the growth has to be reduced with the environmental impact. Then when the product is in the drawing board, the design engineer must think about that how my product will be low weight, same performance, how can use the recycled material, or how after the product use, how it is recyclable. So this type of thinking process should come while designing product. This is called decoupling technology. What is the first model? Model is, as I told you, circular supply chain. When you say circular supply chains, already I explained to you, that means provide renewable energy, bio-based or fully recyclable input of the material and replace single life cycle inputs. That means one life cycle, it is multiple life cycle. You know, second is the recovery recycling. So your product has to be collected. Any used product has been collected, that it has to be recycled. So even the tire industry is surprised to know today, for the 1.2 billion car, more than 3 billion tires being manufactured. Out of 3 billion tire, 1 billion tire, more than 1 billion tire was scrap every year. So where those tires will go? So that means if you dump those used tire, that is the mosquito breeding ground, there is a fire hazards, and environmental pollution because rain is taking all they're leaching out underground water, sea and etc. So these are the certain effect, which is a that in total underground water will be contaminated. I can give an example. In Europe, Western Europe, entire industry using the zinc oxide, about 4 to 5 parts. And they observed that 5,000 tons of the zinc oxide is accumulated per year, whole Europe. So as you know, zinc is a metal automatically is contaminated human life. So the people are working how to eliminate zinc oxide, how to reduce the zinc oxide to the copper. So these are the certain work. Then product life extraction, I already do build to last. Then sharing platform already explained. And last but the not least is the let us considering the product as a service. These are very unique features. How you can use the life extension of the product. Let me be very clear. In JK what you are considering that instead of selling tires, selling miles, the customer won't pay for the tires. Whatever the kilometer they coverage, they pay. And we found that it is a selling miles means, so we have a call, the fleet owners, which has got 1,000 commercial vehicles. So we have a agreement with them and we have a separate cell. They total take the maintenance of the tires. Because so automatically 25 to 30% life enhancement. So your fuel consumption reduced, your mileage has improved, the cost per kilometer has reduced. Automatically the customer is happy, owners is happy, manufacturer is also happy. So this is the model. Instead, if you can give the after sales service, the service as a product, that's the very important. That means your life will extend it for that. So these are the 5 business models people are working on this. Next is the let us very clear what is actually happening in the mobility sectors. Mobility sector is happening. There's got 3 dimension of the nego. Uh, Sorry. So actually, it's okay. Let me be very clear. The what we consider 3 dimension of the new ecosystem. One is the all I told you. See this method. You must have seen the slide rightly. What I before explaining, I can tell you what is actually happening. The automobile and tire industry. Again, the sustainability, sustainable mobility, legislation, regulation, new mobility, emerging technology, performance cost. So what is happening? Global trends, same thing is happening into the, so every industry has to look into that. X-axis is the different product, passenger car and TBR, and the X-axis is the duration, and Y-axis is the passenger and TBR. Here you can find out the one very important point here that is considering in the short span of time is the tire leveling. What is tire leveling? Today, refrigerators, washing machines, they've always put a star mark. So what is the energy consumption? Similarly, tire also leveling is coming by the 3 factors. One is the fuel efficiency, there is a rolling resistance. Second is the safety, there is a dry grip and wet grip. And third is the noise and vibration. Why I will explain this, the tire leveling is important. Suppose electrical vehicles is coming, there is no engine noise. Whatever the noise will be between the road and tire interaction. So automatically the tire has to be completely, there is no engine noise. So you have to consider how to reduce the vibration level in the tire. This is a big challenge. Next, as you pass on, then electrification will come. Then, the connected vehicle will come, then shared, then the sustainability, ultimately commercial vehicle. So next 10 years, what is happening globally? First, in India, what is happening? First, two, three-wheelers, the electrification is going. Then subsequently will come the passengers first, and subsequently to the commercial vehicle. By the time the technology vehicle, the today the petrol and the diesel, whatever gasoline you put, you are not sure that there is all petrol pump infrastructure available. You can go thousands of kilometers or mile, no problem. But the life of the battery is very important. Earlier it was 400 to 500. Now today they develop the battery 1,000 kilometer at stage one. The infrastructure like in US, every kilometers there is a charging station. So there's a lot of technology infrastructure is required for that. Now, if you looked into this is called our three dimension of the sustainable mobility solution. One is the regulatory, that is government. They have to make a legislation pollution. Today, every country is making that old vehicle. After 10 years, you cannot run the vehicle because efficiency is going. In India, for the 15 years part, you have the vehicle has to scrap. And after that, you have to take the re-register. So the regulatory, the policy will come up. Second is the technical innovation of auto industry. That means what is happening in the IT sector, IoT sector, sensor, first reflecting in automobile industry. Subsequently, automobile industry reflecting, that reflecting into the tire industry. So that's what you can say the business innovation, the cross industry. That means automobile industry, the tire industry, and the supplier, they have to work together to make the work toward the green sustainability. So it is not the policy makers alone cannot do, neither the OEM nor the tire manufacturers. Uh, you see, what is the needs and the solution? The needs is the decarbonization. That means how can do it? Lower weight and energy efficiency. So you are less greenhouse gas emissions. Second is the circular economy, recycling waste reduction. Third is the autonomous car. That means what you want, anything, your vehicle should be carefree. That means in between there is no disturbance. So that's the thing, what development is coming. Sustainable mobility leads to sustainable tire and auto rubber components. And then sustainable design, sustainable materials, sustainable manufacturing. And ultimately, you have a solution. If you looked into that, all those things together, everybody has a role to play. Now, next, what I want to say, this is the future mobility already explained. You see that connected. Connected means vehicle to vehicle. That means why there is accident happening. Suppose vehicle, you know that right turn, left turn. So the vehicle will be connected together. So this is called vehicle to be vehicle that should be require infrastructure. And Japan is in this, very much ahead. Then autonomous, electric, and the shared. Shared we know, electric we know, autonomous means simple warning system. There is a camera and radar. Today you know that all the vehicles, the braking distance, there is a 5 meters distance has to be given. The sensor, autonomous car, what they do? If there is a bump or a hump for the front vehicle, they already speed controls. Because sensor is considering directly they control the vehicle, they stop it. That's the called autonomous vehicle with the driverless. And they can notify your voice directly, opening doors and everything will be autonomous. Open the door will open. The sensor will work that one. So number three. Okay. Now next is that is very clear. This is called this is actually how I've already explained to that one. Next, this is the vehicle market, how the EV vehicle is going. Automatically, if you look that way, see all the country, China, Europe, US, rest of the world, and India, everybody's the vehicle is growing, and the right hand side, you can see that the segment wise. This is the drive technology I see to the fully hybrid vehicle, then battery electric vehicle, and the fuel cell. When you convert to one to the others, your rubber components and other will be changed. Let us electrical vehicle, thermal management under the bonnet. If the battery will get discharged, if you cannot control -10 to +50 degrees centigrade, if the temperature below -10, above 50 degree, battery will get discharged. That means heating and cooling system under the bonnet will be totally different. Similarly, if you have got a hydrogen, then hydrogen, as you know that it is a fire hazard, the hydrogen permeability, all the rubber component, then you have acid resistance, And then we have a, lightweighting, vibration, noise. So every change in your vehicle system, automatically drive technology, all the rubber component, because rubber component is give the, these all isolation, insulation given by the elastomeric rubber materials. Uh, these are the electrical vehicle. That means you require a thermal management, you have a lightweight, electrification, noise, vibration, hardness. Now, if you looked into the electrical vehicle, petrol and diesel and etc., total generation, as I told you, electric vehicle city will be cleaner, but the total carbon dioxide generation throughout the life cycle, including the charging, is the highest. And the CNG hybrid will be 89. That is the Japanese, they believe that instead of IC to directly jump into the EV, they are going for hybrid. Uh, these are the things about I already told you. These are the EV vehicle regulation is coming. That means all the rubber components will be halogen free flame retardant. That means, as you know, the halogen containing, they give a toxic gases, chlorine and HCl and other. And this actually, all those things makes the smokes will give a dye. Low smoke emission, self-extinguishing material, all the automobile content beside the tire, lot of other rubber components. Okay. Then we have a material with a limited oxygen index, high LOI, and they meets the regulation. That means you require a thermal management, all the seals and weather strips, what you put in automobile, that will also totally change, and the safety. Next comes about these are the regulations, it's very important. See, what is the upcoming regulation is coming? I'm not calling it exceeding. You call Euro 7, there is a tire abrasion, the tire rubber wear particle. You have a 4-passenger car. Whole life of the tire, every tire let us weight about 5 to 7 kilo. Each tire loses 1 kilo of the rubber particles. And that means 4 kilo rubber particle per passenger cure in the whole life of the tires. This particle may be distribution from the 2 millimicrons to 10 millimicrons and above. 2 milli to 10 millimicrons, they go to the atmosphere. And the below above that, that go to underground water. So the resolution is coming. You have to mention that after the every 100 kilometer, what is the weight loss of the tire at the particular load? That means weight loss per kilo per 100 kilometers. That should be a specification. That means there is no equipment. Now today developing, we have to developing equipments. You have to wear the tire laboratory, collect the sample. What is the aggregate size distribution, particle size distribution? Then accordingly you have to get certified. It's very important. Then comes 6 PPD replacement. This is the total antioxidants that's they found in USA, California state, that when this particle is going underground water, the salmon fish, they die. So now the 2025 December, this will be banned. The USTM and the US Tire Manufacturer Association. This is also very, today we cannot think about replacement of this material, but I will talk about the graphene is one of the things that partly or fully can be replaced with the 6. Then comes the EU deforestation free regulation. As you know, the natural rubber is a common plantation, the forest. They are considering you cannot cut the tree and replant it. You have to go for natural production in the fresh area. That means you cannot deforest. So this called European Union deforestation free regulation. Then compliance by December 24. Then stringent requirement of the fuel efficiency. These are the certain things, very upcoming regulations. This is the 6 PVD. I'm not going how the 6 PVD ozone attacks. Now this is called Deforestation Act. Now new regulation there is obligation applicable by December 2024, and any commodities to be produced legally on land that was not subject to deforestation or forest degradation by December 2025. Now, this due diligence in process, traceability, physical segregation, there will be a certifying agency. They said you have procured natural rubber from a tree which is in the fresh land, not in the deforested land. Then comes about what are the regulations comes? These oil, palm oil, soybean, rubber. So rubber is coming into that deforestation regulation. Then you cannot export to the. So these are the rubber material I already told you. See, in rubber material, there are the two things. One is called reactive material, another is called stable material. Reactive materials means in the factory, what are the fumes we are getting? There is the reactive. This fume may be beside the moisture. You get nitrogen dioxide, you get a sulfur dioxide, you get H2S, you get a carbon dioxide, carbon monoxide, all those things. So these gas really is considered the silane, adhesive, accelerator, sulfur, stearic acid, retarder. These are reactive. Then comes stable material. That means tire wear. These are the particle where the polymer, the carbon black, mineral oil. So we have to consider that the how we can reactive materials with the fumes in the factory, not only the user state, factory also they have to consider. That is the factory has to certify, as I told, international sustainability carbon certification. They will come, auditor will look into that, how we are reducing. Second is the stable material by the legislation, regulation coming TWRP and so on. So these are the whole world trend, how the consumption petrol-based. You see that I have given the left-hand side slide. Natural rubber is the energy, the natural rubber is 8 megajoule per kilo of production, whereas synthetic 110. So more and more natural rubber, then you will risk. Similarly, if it's the carbon black, ultimately you have to go for a silica, the reclaim. The waste rubber is those. That means recycled material we put, tire will be more greener. So these are the trend, how the brown marking is the petrol-based material, green marking is environmental, the fight this today, whole world. Ultimately, by 30 years down the line, you have to reduce the petrochemical by 20%, 50% natural-based, bio-based, and 30% recycled material. This is the trend is going globally, and this is a trend for next 5 years to India. Uh, Next term, this is how the manufacturers are doing. You see the biorefinery. Today, we are making fossil fuel based to synthetic rubber, ultimately from the biomass. From the biomass we have to make. The green line is the circular economy or the renewable or sustainable, or a red line is the today's situation. So lot of, see, I can give you the right hand side, how the sugar biomass from the fermentation, you get a bioisoprene, and from the sugar cane, from the EPDM. So you see they already start. Land says, there's a lot of synthetic manufacturers, the biosource, bioattributed polymer, they have already started. These are the different types of the tire. I'm not going very clear. These are the different materials. So let us consider the nanomaterial, but considering silica or the needle set filler or the carbon nanotube or partly set filler. These are the future material. You can partly replacement carbon, but this type of, because they have got interlocking mechanisms for all the nanomaterials. You get a more reinforcement. 20 pHR of the carbon black, 20 parts can be replaced by 2 to 3 parts of the nanomaterials. I'm not going on these things, how they are different. These are the certain example, how you can from the biomass, the different materials. As you know, the paper industry, the waste material, paper, they consider use all the plant origins and you get a lignin. Now, lignin is the one of the manufacturers tomorrow, partly it will be replaced by the carbon black. And, up to, but the mixing technology has to develop. Whole Europe now research is going for lignin. Now, how this waste from the paper industry can be a source can replace the crude material or different source of the chemicals. And here, similarly, rice husk, silica from the rice husk. This is very important. Now we have done the tires with their silica from rice husk. So a lot of factories coming in India. So this actually, what is the raw material category for ISC, International Sustainability Carbon Certification? One is the bio-based, biocircular, circular, and renewable. They're the 4 categories they make. If you make this tire, the biocirculars means the whatever you can see that I have found. So these are the material. So today, soybean oil, sunflower oil, these can be used by replacing crude-based oils. These are the certain, in case of a tires, we have a natural oil, as I told. Then we have a bio-based silica from rice husk. Then you have a polyester, all water bottle, PET, recycle, you get a polyester tire cord. And we make the tire cord. All polyester bottle we recycle, we make a polyester tire cord. Then we get the reclaimed rubber, recovered carbon, recycled beadware. All the steel is going for recycle, can be going that one. So sustainable carbon black. The USA, one plant is coming 200,000 ton capacity for monolith technology. What they're doing, they are the methane. All biomass, you get the methane. Cracking the methane, they get the carbon and hydrogen and take that carbon to the polymers, hydrogen to the ammonia and fertilizers. So that means necessity the mother of invention. They are giving all the technology developed now. Today, let me consider the amount of tire industry material, over 55 million tons of raw material they consume. And this type of capacity built up for last 75 years. So biowaste, it will take another 30 to 40 years to create that capacity. So this is the how this I can tell you, say the graphene. See how the tire industry, the graphene, graphene has got a previous slide I want to show. Sorry. Yes, graphene has three types. One is called the graphene oxide. Another is called the graphene cells, and next is the pristines. So this is actually a very important material for our industry. The graphene oxide, reduced graphene oxide, or the prophene is a pristine inert from the graphene. Now no shift on organic kinetics. That means benefit of the graphene, it can PM2 antioxidant 100%, 70% 6-PPD can be replaced. Or thermal electrical conductivity, improve fatigue life, reduce permeability, abrasion resistance, 70% the 6-PPD can be replaced by the pristines. But only problem what we're facing is difficult to mix. So your new mixing technology, instead of solid phase, you have to go for a liquid phase. So these are the trends of the rubbers. Actually, I think this already explained to you, carbon black and other. So this slide is very important, how the 7R strategy is working. One is redesign, product design, process design, because when you go for more and more recycled material, same process, same machine may not work. So you have to redesign the process, redesign the equipment, distribution design for use. So redesign the, then reduce weight and so on. Then reuse, recycle. As I told, one is the tire, waste tire can be used as the energy recovery. The tire derived fuel or the boiler fuel or cement clean. Calorific value of tire is equivalent to calorific value of coal. In cement industry, they use a lot of coal. So then you can go replace by tire, but you have to go be inert atmosphere, cannot make the pollutant. Similarly, crumb rubber. Crumb rubber, you can be ambient mechanical or you can do cryogenics. I know this has got a glass tensile temperature below you go, you can make a fine powder. These are called the micronized rubber particle. Then you have a ultra high pressure, UHP. Directly ultra high pressure, you get the total tire crumb. That is a pure ascontinol. Then we devulcanized rubber. That may be a chemical, mechanochemical, ultrasonic, microwave, or the biodesulfurization. Biodesulfurization in the microbiologists, chemists, and dietitians, they have to work together. If you develop an enzyme, you have to take out the sulfur processing from there, you get a virgin polymer. This type of, the lot of research is going on. And then we have a regenerate. I want to go first. So reducing means carbon dioxide. If you do the reducing, you will greenhouse gas emission, pollution prevention, renewable, biomass, biomaterial. If you say the reusable, retrading or regrouping, and recycling, recycle rubber or green carbon. So these are the certain advantage of when you go for a sustainable strategy for materials. Now, this is giving I hope this slide is very, very clear. It's called tire to tire project. That means tire to tire project means you can use this after the tire, you can use the vehicle, and then after you are collecting, and then you granulate, then pyrolysis. In pyrolysis, you get a 4 different component called tire, pyrolyzed oil, close to over 50%. Then you get a carbon black, which is about 30 to 35%. About 15% you get a steel, and the 5% the waste heat or the waste materials. So this automatically, after pyrolysis, you get a recovered carbon black. After pyrolysis, with the tire process oil. Now this recovered carbon black will go to the tire again. Tire process will go to the refineries partly. They do the 5% match with the crude oil and etc. From there, you can go to the sustainable synthetic rubber, because these process oil, you can destructive distillation, different fraction. From there, we go for the different polymers, and then you get a sustainable. So this is called tire to tire. This I'm not going. See, this is the what are the how will you do the when you do the retrading. 70% of the material, raw material handed for 1+2 retrade. Waste reduction, coal reduction. This is a retrading means allows saving of each sector. Your land saving, water saving, material saving, and your energy saving, everything. So that's the how the use of retrading win-win solutions. This is called the pyrolysis. Pyrolysis, how they do, you take the tires, the reactors, and the inert atmosphere, they see that all recovered carbon black and steel is coming, and all the monomers, they converted this oil, you get TP oil, and from there you separate the steel. As I told you, tire pyrolysis oil, recover carbon black, steel, and the gases. And this everything can be utilized. And Australia, I know that we are working with New South Wales University that they call green technology, green, they're this called Green Distillation Technology Corporation, GDTC. And they're doing a very work, completely tire they put and directly they get it inert atmospheres. But the problem is they can give the oil to the refinery, they cannot able to sell the carbon black industry. There is no tire or manufacturing. Okay. So this is actually how the difference between this is the macromolecule, this is the sulfur processing. Now today all crown rubber, what you do, you are reducing the molecularity, not the sulfur. So it is 5 parts, 10 parts, 5 parts is sufficient, reclaimed rubber. Crown rubber also depending on the particles in 5 to 10 parts. But beyond that, you have to do that. That is called devulcanization. That means you have to make the processing the sulfur to be taken without breaking the main chain. That's the call. And biodiesel calculation is also same thing. So that you can go because initially natural molecular is 10 to the 6. So when you process and cured it is 5,000 to 20,000. And if you're reclaiming it below 5,000, very sharp, so their strength is losing. This is called, ultra high pressure water jet techniques. So you can see from the ultra high pressure from the trade end of the life of the gas, 100% environmental friendly because no gases. You are using water, the water can be recycled, no stress, water flow system, high quality. And so this technology is coming very, very popular. No need of tire, anybody can do it. This is not that much of high tech. I'm going that, let me very clear. This, yes, this is the last slide. Carbon capturing mechanism, what Exxon is doing. So this is, this slides you might have seen. What they do, this is called these Empire State Building. The depth of the mandal is too, you have to go to underground, such a high below. So whole carbon dioxide, what they're doing, just suppose they are refinery, they're extracting. So when they're extracting, there is a lot of vacuum spaces available. So they're producing, giving the carbon dioxide there, so they will be trapped. This carbon capturing technology. This is the relation between the vehicle change, tire change, and material change. So how they can be considering what is electrical vehicle requirement, what is the tire requirement, what is the material. So it's a very, very important. That means all the research will be considering. Suppose when you go autonomous driving, so all these material has to be conductive material, adhesive engineering plastic. I know this type of different material. Here is the nanofiller, neodymium-based molecular distribution, here the halogenated butyl, and functional is SSBR or functionalized poly. So gentlemen, actually challenges are there itself, as I told you. And this is the future car. Look at how the future car. This future car is directly whatever you have a hydrogen fuel tank. You might have seen fuel cell stop and the body attachments and etc. And this is the carbon heating system, side mounted radiators. So the wheel motors, there all will be sensors. This is the future car, what is the hydrogen fuels. And this is about what is happening, the sustainable aviation fuel. This is for the plane. They're considering that to totally different. Depend on sustainable aviation fuel means is produced from renewable non-petroleum feedstock, including municipal solid waste, woody biomass, waste oil, and agriculture residue, and rich crop with the carbon-rich waste gases. From there, they are actually collecting the oil. Now, 5 to 10% already today, when we consider they have started blending with the fuels. And this is everybody is working in that direction because the plane is one of the highest emitters. Similar to the sea, we do not think we take the cities. The sea there is a diesel. They're transporting how the pollution, the carbon dioxide or emissions are coming in the atmosphere. So that means what is required? Better awareness. And the students they must know. It has to be concluded in the curriculum. What is the future technology? Better awareness is required. Disruptive technology. There is a policy changes, innovative funding model, which is the fund for that, and collaboration and partnership. These are the certain factors critical for the sustainable economics or sustainable development. And that means we have to join hands together. See, just like the computational material science, biosource material, sensor and digital technology, recycling technology is going to shape up the future of the tire rubber industry. Next is the challenges of plenty, most important with the entire society. Difficult to stand alone, you cannot find the solutions. Third is collaborative framework with the entire supply chain is the best way. Support from the government and academic institutions are equally important. There is material manufacturer, component manufacturers, and OEM, there is automobile manufacturer. They have to work hand in hand. So these are our JKTR, what we have done last 5 years, you might have seen. We have a 60% power from the wind and the solar. And water harvesting, about the mostly 3 months we are writing for rainwater harvesting to add a lot of water they consume. You might see the table and etc. Last but not the least, we are the first to India make a passenger tire of 15 and 17 inch with 80% sustainability. So that are commercially being tested. We use the biosource of synthetic rubber, natural rubber, rice or silica, polyester tire cord, recycled polyester tire cord, as well as the what is called soybean oil, esterified soybean oil. These are the things. If you see the whole world map, JKTR is the first in India. We got ISCC plus certifications. Okay, this is in the ISC the website. Uh, and thank you very much. I think so. The time is very short.
Show the video.
Yes. So this is our what I want, the social, economic, environmental. That means we require oxygen. We don't require CO2. I hope all of you agree with this for our survival. Now I think so. With I have a certain video film from our research institute. You can get an idea what this Indian about our more than 400 crores. That is the Indian rupees. I don't know what should be the Australian dollars. We have invested for the R&D. This is a this is our institute. This is our reception area. Infinite, you are giving the research as not fixed. It is infinite. This is our activity, what we do. The grief and stress will I do that. So you can sleep. Our advancement in future medicine. Correct emission all of different temperature, different possible. Is there a lab? Is a pilot plant? Simulation based. That would be very effective actually. Two-wheeler, motorcycle cells. From B to B, you can say where they run out. The fuel efficiency, loading distance, where also speed, camber, and the durability test. It's inlet growth condition on the side. The OTA issue, the mine science, all the it's a road test. Or learning test. It's a double lane change, or changing the lane. It's a ski test. Portion moment no sleep. Wait, brief. Wait, keep on commercial. So the vehicle has to run 1 minute, 80 kilometers, then engine stop it. Then you see the vibration noise. Your anechoic chamber. So or this is two-wheelers. The completely four-wheelers come directly. You see the vibration. There is a microphone. They capture the vibration sound. See the machine called 50 Pro, one machine, for the portion moment. But all OEM, they get the data. See, this is the road, tire, then the vehicle. You don't need a vehicle system. We can simulate in the tire. You can camber, load, speed, everything we can keep it. Trying the 3-4-3 moment. We have our own calibration report. All sales and other, because all calibration is very important for all everything. Calibration. We have environmental data, water analysis, excellent analysis, gas analysis. It's our lecture room. All Nobel laureate, those were in tire and polymer industry, picture is there. Thank you. This is our center, totally environmental friendly building, all natural light. Thank you very much. Any questions? Sir?
Yeah. Question from the audience, sorry. Yeah.
Excellent presentation, futuristic. Details.
Yeah. Any question from the audience? From us? Anyone from here?
What you have just
Yes.
Is
That okay?
Yeah.
Mm.
There's nothing on the chat.
Yeah.
But obviously, given the time,
Yeah.
if there was
Some
one or two
people have
questions,
left,
feel
yeah.
free to
Any question from
let us know.
audience here?
Hello, can you hear me?
Yeah, we can hear you.
I know I thought that was very informative. I've got lots of information myself to provide at some stage, but yeah, no, I found that very interesting. No real questions. I'd like to go back and see some of the slides that you skipped over. There were the ones that I was more interested in,
Okay.
exploring
Mm.
the ins and outs, the tires, the chemistry. But no direct questions on this presentation, except that I thoroughly enjoyed it.
Thank you.
But if you have any question on your retrading and other, you can ask.
Just a quick question, probably I can ask.
Yeah, please.
Yeah, so very futuristic presentation. So talking about all the future, what we will have to do and have to do in both not only tire but also in other space also. How it become more sustainable. Of course, tire industry has to change. The tire is going to start using cellulose and type of material and all the processing, everything has to change. And that's a huge step, but also important step because cellulose is infinite almost. You can grow them and then you can use them. That would be the real thing. But I would really touch on another aspect of which is you said that the electric vehicle is one of the futuristic things. But electric vehicle, in my opinion, is not really future because you have to generate the energy. So right, if you are burning coal to create the energy and they are using it, so you are basically creating a pollution in somewhere else, not in the city. That's a kind of selfish technology, I would say. The pollute everything what you can, not in the city. Please, that's what it is all about. And also the battery technology, it is not really also very environment friendly otherwise because we are using lithium, right? Lithium ion type of things. So lithium is not really very friendly either. You have to get it from mining, and if it is polluting the water, that's a big issue. In Australia, we are facing that because we have opened some mines and then it polluted water. And then recycling may be another issue when the life has gone. So this huge amount of lithium, you'll have to dump it somewhere or to do something about it. Same question may come as it is in the nuclear. So where is the solution? Is it really solution or we are waiting for some other problem? Because once upon a time, I can remember in my childhood, plastic, people are so excited about disposable plastic. Now this is a real disposable plastic is a real issue and concern in the whole world. And it is become one of the number one pollution in the world. So whether we are waiting for that kind of scenario, if we really go for lithium battery technology, what would be your just opinion in that?
Actually, there are 3, 4 questions you asked simultaneously. Number one, as I told you, electrical vehicle will make the clean city, urbanization, sir. That point. As I also told, 2/3 of the population will live in the cities by 2050. Please understand. So city has to be first cleaner. Now, second point is you require infrastructure for charging battery. Now, I told you, as long as battery you get a thermal source, it is not environmental, but in total supply chain. But what is the going on? One is the weather. Tomorrow maybe that your car in the hood, there will be solar panel. There will be the solar window. You know, the another things, while tire is running, there is energy loss, the piezoelectricity. So whether the energy is lost, being a viscoelastic material can convert to electricity. So that means while the vehicle is moving, that energy what you are losing, that can be converted into the charging of battery. This is one way, so that research is going on maybe 3 to 5 years down the line. We are also doing the work. That is very clear. Energy losses with the sensor, that will go. Second point is all about the non-pneumatic tires, which are not told, the time is not work. There will be a flexible spoke instead of rim, there will be metallic hub, 3 components, or the Michelin supply for defense and etc. So your first question is the battery to be charged by the solar, okay, or certain other green alternative energy, or by the energy losses from the tires. So the problem. Now, question of the lithium, that is very clear. Today, as well, line, we found that the lithium battery will give you the 1,000 km plus. The question is the lithium extraction today to be problem. So there is a search for alternative battery material, more effectiveness and other. The research is going on because necessity is the mother of invention. Today, biosource synthetic rubber, we never thought is coming. We thought that, it's not possible. Same strength and other, etc. We already got it. Now, third question is those government, there are certain, how we can protect it, the mines, lithium, also extraction and other, can you make environmental friendly? The effluent treatments and other, the way the carbon dioxide, because we have to survive, we have to produce the product, there will be greenhouse gas emission. How we can absorb those greenhouse under the ground once. So similarly, the lithium. So today, what is a mercury battery? Let us very lead acid cell battery. What you are doing? We are recovering the mercury. We are doing this one. So there is the innovation. That is the basic research one has to do. That university has to do. Third question: what you considering?
Well, but you also talked about briefly about the fuel cell technology.
Fuel.
You're talking about
Hydrogen.
fuel, why it is not hydrogen?
Let us consider the first is the fuel cell, followed by the hydrogen. Now, hydrogen production globally, if you look into that, about $2.5 to $3. In India, Reliance, they're spending thousands of crores to supply green hydrogen. One, you know that he's at Stanford University. You have a think tanks in Stanford Institute. Somebody. They are doing about more than 1,000 crores for the green hydrogen. You're surprised to the amount of area they covered. Fantastic. Long, they are expecting by 2030, the greener hydrogen will be realistic. That's our government is also saying. If hydrogen also they call brown hydrogen. There's a white hydrogen and the green hydrogen. So you can give the hydrogen different process. What you require green hydrogen. How you can do it? How can do it green hydrogen? Take the water, split it, and then you get the green hydrogen. So that ultimately it is the water will be the give the better solution compared to any others. What I want, see this type of research going across the world, and it's a question of time. And this question of today there is biosource material. Today synthetic rubber, total rubber consumption is about 30 million tons. Out of synthetic rubber 16, natural rubber 14. Now the 16 million tons you cannot do the capacity from biosource. So it will take time. So people and nobody scrapped the existing factory. It has to be go gradual. So a lot of as long as you keep the environmental temperature 2 degrees centigrade and below rise, so you're safe. Do not allow this. I have not shown that graph. The cushioning effect, the combing effect. The combing effect means business as usual, business for trends, and it will be press that one. Otherwise, in China, simple example, there are 450 tire companies. Today only 75. So all the polluted tire companies, they stop it. Questions today, the government legislation regulation, they force the polluted industry to be closed. And so far, it is very clear, the California state, whatever considering 6 ppd ban. So there are certain environmentalists, they're working continuously how the human, this thing. Now, there's the zinc oxide elimination. People are 4 pH to 1 pH come active zinc oxide. Now, people are considering whether such type of, any other metal can, selenium, tellurium, but the question of the availability cost, whatever you develop is a cost performance ratio is very, very important. Am I clear?
Yeah, cost is the primary.
Yes, we can
Yeah.
stop this one and
Yeah,
then
okay.
jump for stop, yeah. Hi, everyone. So if no other question, let us give a big.
Question from young.
Yes, I'm not sure they are not asking.
Have you understood or not? Yes or no?
Yeah.
Once again, thank you to the RMIT, the management to make this arrangement, especially thanks, Nita and yourself both.